Okay, we've got this polynomial function right here, written in factored form. In this form, it's easy to tell what the roots are, the values of x that set y equal to 0. That would be 9, 10, and 0. And that's these points right here. This red graph is the graph of the original function, which has end behavior as x approaches negative infinity, y approaches positive infinity, and as x approaches infinity, y approaches negative infinity. So some textbooks say that the end behavior is up, down. Question is, how do you figure that out? Just by looking at this function in factored form? Well, you could think I'm going to expand all these binomials, multiply everything together to find out what the leading term is. So if you square x minus 10, you get this trinomial. If you then multiply x minus 9 times that trinomial, you get x cubed minus 20x squared plus, in other words, I'm just multiplying every term here by x, and then every term by negative 9. Now, if you distribute this negative 5/8 x to the 14th, you get the leading term, negative 5/8 x to the 17th. That's the term that determines the end behavior because it's got the highest exponent. And that's what this purple or blue graph is. You can see it has the same exact end behavior. So if we could easily find this leading term, we could identify the end behavior of the original function. And so the idea is just to picture, hey, if you square x minus 10, you're going to get an x squared. And then I've got this x here. Don't worry about the rest of it. Okay, so if I take negative 5/8 x to the 14th times x squared times x, I'm going to have x cubed times x to the 4th. There's the leading term right there. And now how does that determine the end behavior? Well, I don't know if your textbook has you doing this. The limit as x approaches infinity, I'll put a plus there for emphasis, of negative 5/8 x to the 17th. As x approaches positive infinity, this term is positive. Some big, huge number. But then if I multiply that by negative 5/8, it'll turn negative. That's why the end behavior as x approaches or gets really large is negative infinity. And if I take the limit as x approaches negative infinity of that same thing, as x has really big absolute value in the negative direction, I've got negative 5/8 times, well, since the exponent is odd, I've got 17 negative factors. That's going to give me some big negative number in absolute value. And negative times negative is positive. And that's why the end behavior to the left is positive infinity or up, down. Okay, and I put on board 2 a bigger version of the graph. You can see here are the zeros of the original function, 0, 9, and 10. And as x starts to get big in the positive direction, I've already got negative 4 times 0.7 times 10 to the 14th. That'll move the decimal point 14 places to the right. You can see some huge number. And in the negative direction, 4.75. Move the decimal point 17 places to the right. You got a big positive number. Okay, there you go. Hope that helped. If you have any questions, post a comment.